somewhere above the orbit of Jupiter, moving through the dark at more than 60 kilometers every second, there is an object that does not belong here. It did not form in our solar system. It was not born from the same cloud of dust and gas that gave us the sun, the Earth, or the Moon. It arrived from somewhere else entirely, a wanderer that has drifted through interstellar space for longer than our species has existed, and for a few short months it will pass close enough for our telescopes to watch. And yet, if you go looking for the full story, you will not find it easily. You will find fragments, cautious statements, peer-reviewed papers buried behind technical language, official channels that update their data in small, careful increments weeks apart, as if every sentence has been checked twice before release. This is not the first time. It happened with Oumuamua in 2017, the first interstellar visitor ever confirmed, a strange, elongated object that sped up in a way gravity alone could not explain. It happened again with Borisov in 2019. And now it is happening a third time with an object astronomers have designated 3I/Atlas, the third confirmed interstellar object ever detected, and by far the most closely watched. So the question people keep asking is simple. If this is one of the most extraordinary discoveries in the history of astronomy, why does it feel like nobody in an official capacity wants to talk about it? The truth is stranger, and in some ways more interesting than a cover-up. It has to do with how science actually works when it collides with public fascination, and with an object that keeps breaking the models built to explain it. Let's start at the beginning. In the summer of 2025, an automated sky survey system designed to catch fast-moving objects flagged something unusual. Most of what these systems catch are asteroids, comets, or space debris, objects with orbits that loop around the sun in predictable ellipses, bound by gravity the same way Earth is bound. This object's path was different. It was moving on a hyperbolic trajectory, meaning it was never orbiting the sun at all. It came from outside, it will swing past, and it will leave never to return. Once astronomers plotted its trajectory backward, they realized it had been traveling through the galaxy for an unknown span of time, possibly billions of years, before gravity ever brought it near us. That alone would have been enough to make headlines. But then the details started arriving, and each one made the object stranger. Spectroscopic analysis, essentially reading the chemical fingerprint of light reflecting off the object, showed a composition that did not match typical comets from our own solar system. Certain gases were present in unusual ratios. The way its brightness changed as it approached the sun did not follow the smooth curve astronomers expect from a simple ball of ice and rock. Something about its outgassing, the way material boils off its surface as it warms, looked unusual. None of this on its own screams impossible. Comets are famously unpredictable. Everyone we've ever studied closely has surprised us in some way. But interstellar objects are especially hard to model because we have only ever seen 3 of them, and no 2 behaved alike. This is where the story usually gets exaggerated online, and where it's worth slowing down and being precise, because the real science is compelling enough without embellishment. A small number of scientists, most prominently a Harvard astrophysicist who has built a career on taking unconventional interstellar hypotheses seriously, have publicly floated the idea that some of this object's behavior is difficult to explain with natural comet physics alone, and have argued the possibility of artificial origin should not be dismissed outright before more data comes in. This is a real, published scientific position, not internet rumor. But it is also, by that same scientist's own admission, a minority view. The overwhelming majority of astronomers studying the object, using the same public data, argue it is almost certainly a natural object. An ancient, chemically unusual comet or icy body, ejected long ago from a distant planetary system, behaving in ways we simply haven't modeled well yet because we've never had a specimen like it up close. So why does it feel like silence? Because of how modern astronomical institutions actually communicate, and it has almost nothing to do with hiding anything. Space agencies like NASA and the European Space Agency do not announce discoveries the way a breaking news outlet does. Their process is slow by design. A telescope captures data. That data gets calibrated, cross-checked against other observatories, and submitted for peer review. A process where other scientists try to poke holes in the conclusions before they're published. Only after that does an agency typically put out an official statement, and even then, the language is deliberately conservative. Scientists have been burned before by premature claims. Think of the 1996 announcement of possible fossilized microbes in a Martian meteorite, a finding that made front-page news and was walked back over the following decade. Institutions like NASA now build in caution specifically to avoid repeating that embarrassment. That caution looks, from the outside, like reluctance. It looks like an agency that knows something and won't say it. But in most cases, what's really happening is that the agency simply doesn't have a firm answer yet, and would rather say nothing than say something wrong. There's also a mismatch of timescales that fuels the sense of a cover-up. The public wants an answer within days. Science, especially when studying a single fast-moving object that will only be observable for a matter of months before it's lost in the sun's glare, often can't deliver one that quickly. Data has to be gathered from multiple observatories around the world, sometimes from space telescopes with limited and heavily booked observing time. Every additional data point takes weeks to schedule, capture, and verify. By the time a solid answer is ready, the internet has already moved through several cycles of speculation, half-truths, and clickbait. And speculation online moves far faster than peer review ever could. Within days of 3I/Atlas's discovery, video after video appeared claiming the object was slowing down unnaturally or changing color or emitting radio signals, claims that, when traced back to their source, were either misreadings of preliminary data or, in some cases, entirely fabricated. Meanwhile, actual astronomers were still waiting on telescope time to gather the next round of real measurements. The gap between what people wanted to believe and what could actually be confirmed became the space where every conspiracy theory took root. This is not unique to space agencies. It happens whenever an institution built for careful, incremental verification meets a public conversation that runs on instant certainty. But it would be a mistake to say there's nothing genuinely mysterious happening here. There is. We do not yet have a confirmed, unanimous explanation for every observed feature of this object. The solar system has now hosted 3 confirmed interstellar visitors in less than a decade, after detecting exactly 0 in all of recorded human history before that, which itself tells us something remarkable. These objects are far more common than anyone expected, drifting through every stellar system on a timescale we're only beginning to grasp. Each one has arrived with anomalies. Oumuamua's strange acceleration was never definitively explained. The leading natural theory, invisible outgassing of hydrogen, remains unconfirmed. Borisov looked more like a familiar comet but still had a chemical composition richer in carbon monoxide than anything seen from our own system's comets, suggesting it formed somewhere far colder than home. And now 3I/Atlas has arrived with its own list of open questions. Rather than evidence of a cover-up, what this really represents is something rarer and, in its own way, more thrilling: the frontier of human knowledge live in real time. We are watching scientists build the airplane while flying it, refining their models of interstellar chemistry and dynamics with each new object, because for the first time in history, they have real specimens to study instead of just theory. Consider what it actually means that 3 interstellar objects have now passed through our neighborhood since 2017. Extrapolating from that detection rate, astronomers estimate that at any given moment, thousands of interstellar objects the size of 3I/Atlas or larger may be passing through the solar system, most too small or too faint for our current instruments to ever notice. We are catching the rare, larger ones purely by chance, purely because our sky surveys have only recently become sensitive enough to catch a fast-moving speck of light against 100 billion background stars. Each of these visitors carries with it a kind of message, sealed in ice and rock, about the star system it came from. A system we will never visit, may never even identify, light years away, possibly extinguished long before its comet ever reached us. The chemistry embedded in that object is a direct sample of another solar system's formation, delivered to our doorstep by nothing more than gravity and time. That is the real story here. Not silence, not suppression, but an object almost too strange for the language of press releases to keep up with. A discovery so new that the agencies studying it are still, quite literally, working out what to say. There is a deeper irony in all of this. The very caution that looks like secrecy is actually the opposite of secrecy. Raw data from missions studying objects like 3I/Atlas is, in most cases, made public specifically so that independent scientists everywhere, not just those inside a single agency, can check the numbers themselves. The reason so many competing theories exist right now, from mundane comet physics to speculative artificial origin hypotheses, is precisely because the data is open enough for anyone with the right expertise to draw their own conclusions from it. A true cover-up would look like empty archives and canceled observing time, not a flood of publicly available spectra that both mainstream astronomers and unconventional theorists are actively arguing over. What NASA and other institutions are actually being careful about is not the existence of the object, or even most of what we know about it that's already public. What they're careful about is language. The difference between "we cannot yet rule out" and "this could be," between a hedge and a headline, is often the difference between responsible science communication and a story that spirals out of control across the internet within hours. Scientists have learned, sometimes painfully, that the wrong choice of words can turn a genuinely fascinating natural mystery into a viral myth that takes years to unwind. So when the next data comes in, and it will, because 3I/Atlas remains under observation by multiple telescopes around the world, including some of the most powerful instruments ever built, expect it to arrive quietly. Paper, a dataset, a short, carefully worded statement. Not because anyone is hiding the truth, but because the truth, in this case, is still being written one careful measurement at a time. And maybe that is the more honest kind of wonder. Not a secret waiting to be exposed, but a mystery still unfolding in front of us, in real time, visible to anyone patient enough to watch it happen. Somewhere out there, a fragment of another star system is passing through our own, carrying chemistry older than our sun, and for a brief window in human history, we get to watch it go. We may never fully explain everything about it.